All right, hello everyone. So today we're going to be focusing on graphing inequalities on the coordinate plane. So when graphing inequality in two variables on the coordinate plane, we follow the same procedures as graphing an equation with two exceptions. The line can be solid or dashed, and we need to shade a region of the graph. So first off, when you are given an inequality and you have either the less than sign or the greater than sign, that'll give you a dashed line. So go ahead and write that on your notes that'll give you a dashed line for both. All right, and when it's less than, when that symbol is less than, that means that you're going to shade below the line. And of course, similarly, when it's greater than, you're going to shade above the line. Oh, let me say shade above the line. All right. And so the next thing that I like to do when I have to come up with a line for my graphs, I like to substitute my inequality symbol for an equal symbol so I can easily create a table of values. And since I would do that, this y is less than x, I'm going to say that y is going to be equal to x. And the same thing would be true for the y is greater than x. I would just substitute that greater than symbol for an equal symbol. So I'm just going to use the exact same equation for both of these, which means I'm going to create the same table of values. All right, so I'll have my x's and I'll have my y's. All right, and I just come up with random values for x because that's my input. I can choose whatever I want for that. All right, so since my equation says y is equal to x, then when x is -2, my y is -2, and so on and so forth. And now I can go ahead and graph all of those points on my coordinate plane. So I've got -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. And I can easily see what my pattern's going to be. So I'm going to go ahead and plot. Ooh, and I did it wrong already because we said it's supposed to be a dashed line. So we're going to make that line dashed. And make sure you don't forget about your arrowheads. Now, the final thing that we have to do here is we need to shade below that line because it says that y is less than x. And we're going to check our solutions. We're going to see which of these points are parts of our solution based on what we've graphed. So we're given the 3 points to start off with. So we have -3, 2, 0, 0, and 2, 1. So what we're going to do is we're going to look at -3, 2 first. So I'll use a different color here. Maybe not this purple. All right, so -3, 2 is here. I can see that it's in the non-shaded area of my graph. So that means that it should not be a part of my solution. So let me make sure that I've done this correctly by checking my inequality. So I'm going to plug this value into my inequality and see if I get a false statement. If I get a false statement, that's when every time I get a false statement, it should be in the non-shaded area. So that's when my inequality is false, which means my inequality will be true if that point lies in the shaded area. All right, so when I plug that in, my y, of course, since this is a point, it should be x comma y. So my y is 2 and my x is -3, and the inequality symbol was less than. So is 2 less than -3? No, that is a false statement. And since it's false, I know that I've shaded correctly, and that is not part of my solution, so I'm going to cross that out. All right, next, I'm going to move on to 0, 0. Well, I see 0, 0 is right here. It is on the line as my origin. All right, since it's on that line, and I'll use a different color again. Since 0, 0 is on the line, I'm going to know that since I have a dashed line, whenever I have a dashed line, points on the line are not part of the solution? All right, since that's not part of the solution, it's not a solution here, of course. So I'm going to cross that out. And the final point that I have is 2, 1. So I'm going to plot that point, and I can easily see that it has landed in my shaded area. Since it's in my shaded area, it should be a part of my solution. And again, I'm just going to check it real quick to make sure. So I got x, y again. So I'll have 1 and 2, and then it should be less than. Is 1 less than 2? That is a true statement, which means that is part of my solution. Perfect. So everything is correct. We've easily identified which of these is a part of our solution, and we are good to go. All right, moving on to the next one, I can see, like we said, we're going to use the exact same table of values. So I'm going to go ahead and plot those points again, those exact same points that we had before. And that's still going to be a dashed line because I have greater than as my inequality symbol. But this time, since it's greater than, instead of shading below the line, we're going to shade above the line. So we're going to shade right here. All right. And so now we have to check these solutions again. So we know we should be right because we just did the exact opposite of what this first problem was. So I shouldn't have to check my inequality again because I know I've done it right. So all I have to do now is just plot my points. So -3, 2 lies directly in the shaded area. So that is part of the solution. And it is because it's a part of the shaded area. 0, 0, again, it is on the line. That's our origin. Since it's on the line, we're going to refer to this over here, where the points on the line are not part of the solution. So that is not a solution. And finally, I have 2, 1, which is in the non-shaded area. If it's in the non-shaded area, that is not part of our solution. Okay, and again, we said that 0, 0 was not a part of our solution because it was on the line. And we are done with these first two. All right, then we have the bottom two, which again, if I'm going to rewrite these inequalities as equations, I would replace the inequality symbol with an equal sign. So I'd have the same equation every time. So I'm just going to copy that. And I'm going to use that exact same thing at the bottom. All right, and go ahead and plot all my points. And I'm going to do it for the left and the right because the same type of thing is going to happen. And again, this only works because these are just example problems, so it should be pretty easy for us to follow. So this time, what makes these different from the top is the top equations had less than or greater than. Okay, so we have that dashed line. Now we have less than or equal to or greater than or equal to. And let me use a different color for those. These are totally different. So when I have the or equal to part, that means that whatever's on my line, it will be included this time. So instead of a dashed line, I'm going to have a solid line. And like we said, it's going to be the opposite. So for a dashed line, the points on the line were not included as part of the solution. But on a solid line, the points on the line, they are included in the solution. All right, and since they're solid lines, I'm going to go ahead and graph that line. So it's a solid line this time. And both of them were exactly the same, so I knew I could go ahead and do that. And just like above, we said when we have y is less than or equal to x, again, this is what I'm talking about. Y is less than or equal to x. That's what that means. Oops. So since I have that, less than is telling me that I'm going to shade below that line. And on the flip side, on the right, I have y is greater than or equal to x, so I'm going to shade above that line. Okay? And now I just have to decide about these solutions. So let's start off with -3, 2. So I have -3, 2, and it's easily not, it's in the non-shaded area. Since it's in the non-shaded area, it is not part of our solution. We move on to 0, 0. That is our origin, and it's right on the line. So this first one was in the non-shaded area. This next one is on the line. And since it's on the line this time, and it's a solid line, it should be included as part of our solution. And finally, we have 2, 1, which is here. That is in the shaded area. So that means it should be part of our solution. And again, just to check to make sure, you can just choose either of those that are that we've said are in our solution. We can plug them in and see if we were correct. So let's choose 2, 1 and plug it into our equation. Or I'm sorry, into our inequality. So x comma y, our y is 1, our x is 2. 1 is less than or equal to 2. That is true. And remember that for it to be true, it should be in the shaded area. So we're correct. All right, same type of thing on the right. So let's go ahead and plot -3, 2. That is in the shaded area. Since it is there, it is part of our solution. 0, 0 again is on the line. Since it's on the line, it is part of our solution since we're dealing with a solid line. And finally, we have 2, 1. That is in the non-shaded area. So it is not part of our solution. All right, and that is it for the first half of our notes for today. All right, moving on to the back page. Now we're going to actually get into what our normal inequalities are going to look like. All right, so we're going to graph the inequality on the coordinate plane. Then we're going to circle all the possible solutions to the inequality. All right, so again, like we said, we're going to start off by rewriting these inequalities as equations so we can create a table of values. Again, you don't have to do this if you don't want to. You can always just graph the line like normal. And I'm actually going to do that for our next example. Okay, so I'm going to start off with my table of values first. So I'll have x and I'll have my y's. So I'll have y equals 3x minus 2. I'm going to choose some random values again. So let me choose -1, 0, 1, 2. All right, so -1 times 3 is -3, minus 2 is -5. 0 times 3 is 3. I'm sorry, 0 times 3 is 0, minus 2 is -2. 3 times 1 is 3, minus 2 is 1. And finally, 3 times 2 is 6, minus 2 is 4. So I've got my table of values. I'm going to go ahead and plot my points. -1, -5, 0, -2, 1, 1, and 2, 4. I'll go ahead and draw that line. Well, I see that I have y is less than 3x minus 2. That should be a dashed line. And I should shade, since it's less than, I should shade below that line. Okay, so it should be a dashed line there. And my line looks all kind of crazy. And I'm going to shade below. So I'll shade here. And again, if you're ever concerned that maybe you shaded in the wrong area, you're just going to look and see at your solutions and plug it in to see if you were right. Okay, so let's start with -3, 2. Well, that is over here. Let's plug it in. That we should get a false statement when we do that. Remember, the non-shaded area should give you a false statement when you plug in your inequality, or plug in that solution to your inequality, and the shaded area should give you a true statement. So let's plug in -3, 2. So remember, it's always x comma y. So our y is 2, should be less than 3 times -3 minus 2. Well, 3 times -3. Oh, okay. Yeah, so 3 times -3 is Negative 9 minus 2 is negative 11. And it's saying that 2 is less than negative 11. Well, that's false. So that means we did ours correctly. We should have got a false statement, and we did. All right. So that means that is perfectly right. And negative 3, 2 is not part of our solution. So we know we shaded it correctly. 0, 0 is our origin, and that's also in the non-shaded area, so it's not part of our solution. 1, 4, again, not part of our solution, it's in the non-shaded area. 2, negative 5 is definitely in the shaded area, so it's part of your solution. 0, negative 2 actually is on our line. It's right here. And since it's a dashed line, any point on that line is not going to be part of your solution. So that is not a part of that solution. Negative 4, negative 2 is over here in the non-shaded area. So it's not part of your solution. 2, 2 is in the shaded area. That's part of our solution. And then we have negative 2, positive 3, non-shaded, and 3, 0 is in the shaded area. So we had 3 of these points were a part of our solution. All right. And we have this last one that was part of our classwork, and then the last 4 on this page were your homework. All right. So again, this time, instead of creating that table of values, I'm just going to rewrite this inequality as an equation. So negative 2/3 x plus 4. And I'm going to graph it as I normally graph a regular line. So I'll start at my y-intercept, which is 4. And then I'll use my slope to move. So I'll go down 2 and right 3. And I can't really do that anymore, so I've got my line. And again, I've got a less than symbol, so that's going to give me a dashed line. And I'm going to shade below. All right, so I've got my dashed line. Oops, I don't think I did that part right. A dashed line. And I'm going to shade below like we said. I'm going to shade all the way down here. All right. Okay. So again, I'm going to make sure when I'm looking at negative 3, 2, it's in the shaded area. So let's check and make sure that we did that correctly. So our y is 2, should be less than negative 2/3 times our negative 3 plus 4. Negative 2/3 times negative 3 is positive 2, plus 4 is 6. Is 2 less than 6? That's true. So negative 3, 2. It is part of our solution, and we've also made sure that we did this correctly, which is why I plugged it into my inequality, so we are right. All right, let's continue. So 0, 0 is also in the shaded area. 1, 4 is not in the shaded area, so that is not part of our solution. 2, negative 5 is in the shaded area. 0, negative 2, same thing. Negative 4, negative 2, shaded area. 2, 2 is still in that shaded area. Negative 2, 3, same thing. And 3, 0 is also shaded. So on this one, there's actually only one that was not a part of that solution, which was 1, 4. All right, and that was our classwork for today. All right, thank you.